I've had a few questions about significant figures and doing some conversions. So let's start with the conversions and we'll kind of walk through significant figures while we do that. So for conversions, one of the things that you're probably going to need are conversion tables. So here is an appendix out of one of my textbooks. A lot of textbooks will have the conversion tables inside the covers, or they'll have it as an appendix, but you can see that we end up with a conversion factor table and that we utilize this quite a bit. So this gives me conversions in terms of length and mass and volume, temperature, speed, and pressure. Now, as you probably have seen or heard, it's on one of the videos that I had already provided, or in the class, we talk about significant figures telling us where the precision of the measurement is. So if I look at those significant figures, and we'll come back to this conversion factors, if I write a number 567.35, and I have got my 0.35 here, this actually has 5 significant figures, and it's significant to 2 figures past the decimal place. Each figure represents part of that measurement, but this is telling me that this, if I'm doing this in terms of meters, this tells me that this value is actually measured to a millimeter, because remember, in meters, in 1 meter, there's going to be 100 centimeters, and in 1 meter, there is 1,000 millimeters. So this is going to be measured to the single centimeter, not millimeter. So it gives me the precision of the measurement. So if I'm looking at any value per se, so I'm going to do 0.003612, this actually has 4 significant figures, because this value here and that values there are zeros that are placeholders. They only are going to tell us where the place is. And one of the ways that I can tell that those zeros are just placeholders is if I write this in scientific notation, and this would look like 6.312 times 10 to the minus 3, because this is, you do the 1, 2, 3, and it gives me my 10 to the minus 3. All of my digits, when I'm doing scientific notation, are going to show up as significant. So that really does help us out. So if I write a number like 1200, this, as it stands, is only going to have 2 significant figures, because the 1 and the 2 are only non-zero digits, and these zeros are just placeholders. Now, if I wanted to tell you that those zeros were actually significant, for example, I could write this as 1.20 times 10 to the third, and that tells you that that zero really is a significant figure. Or if I want to show that all 4 of those are significant, I can put the 1.2 and then put a decimal point there, and that shows that both of those zeros are significant. So this would have 2 significant figures, this one has 3 significant figures, this one has 4 significant figures. Now the rules, like in the video that I showed, if I'm multiplying and dividing, we're going to keep our answer in the smallest number of significant figures. So if I'm doing 32 times 161 times 45, and I go ahead and punch that into the calculator, so we're going to punch that into the calculator so that you can see it. I get 32 times 161 times 45. I've got a number that the calculator gives me is 231840. Not all of these are going to be significant figures. Let's look at the significant figures of this one. This one has 2 significant figures. This one has 3 significant figures. This one has 2 significant figures. So my answer needs to be in 2 significant figures, because this is the lowest number of significant figures. So when I actually write this out, I'm going to write this as 23,0,0,0, and that would be the answer that Connect is probably going to be looking for if it's telling me I need to be accurate in significant figures. Since I'm doing this video for a couple of different classes, I kind of want to highlight that. If I'm in my Concepts of Physics class, I'm going to be worried about my significant figures there, and in that class it kind of just really looks at it and it may tell you exactly how many significant figures I have. My Concepts of Chemistry class, you really are, because in chemistry, knowing where these significant figures definitely relates back to my measurement, and I need to know the precision of my measurement. So I'm really going to be persnickety about significant figures in that class. And in that class, in your first chapter of the book, go back and look at your math toolbox. That book has a really good math toolbox in there that's showing you how to do scientific notation. It shows you and it refreshes how to do the significant figures and how to take care of significant figures and looking at it from that perspective. So you may be doing this for a couple of different classes, and so I just wanted to highlight that for you. So if I were adding and subtracting, significant figures are handled a little differently. So let's take a different piece of paper here and we can do our addition and subtraction. And in that case, we want to keep the place of the values. So I'm going to do 1200.10. I'm going to add 305. I'm going to add 12.345. And I'm going to go ahead and add these together. And I'm going to get 5, 4, 4, 7, 1, 5, 1, and that's what my calculator would provide for me as well. But in the case of addition and subtraction, we want to keep the lowest place, or the value with the lowest place. Now this one is measured to more precision than that value, and this one is measured to more precision than that value as well. So this is what the one that's going to be driving my significant figures. So just as a reminder, this one is going to have 1, 2, 3, 4, 5, 6, because this 0 is past the decimal point over here. This is actually providing me information. It is not a placeholder. So this one has 6 significant figures. This one has 3 significant figures. And this one has 5 significant figures. But my answer is going to be controlled by this value right there. So what I'm going to report is 157. So that's what I would actually report into my homework solution. So I've got that particular aspect of it. Now, if I'm multiplying or dividing, I'm going to have my answer in 3 significant figures. Addition and subtraction deals with the place of those significant figures. So that gives you that idea of where things are. Now that brings us back to our conversion factors, because a lot of confusion comes in with the conversion factors in that, how do you know what the number of significant figures are in a conversion factor? Because if I give you just a number, like the number 1, it actually has an infinite, if I'm counting like 1 egg, it's going to have an infinite number of significant figures. So my counting of 1 egg isn't necessarily going to control how I'm doing my addition and subtraction, or how I'm doing something like that. I have a lot of infinite conversion factors. So 1 inch is equal to 2.54 centimeters. So if I'm going to do a conversion and I'm worried about my significant figures, my conversion factor isn't going to control my number of significant figures. So that's where we have to look at it. So when I'm looking at my conversion factor sheets here, I can kind of make the assumption that if they're not giving me a whole lot of significant figures, that maybe I'm going to use my data to drive my significant figures rather than my conversion factor. So, for example here, now we also know that this is an exact conversion, so I do have an infinite number of significant figures. I have down where I'm getting something here, that 1 pound, I'm likely to consider that an infinite number of significant figures and use my kilograms to dictate my significant figures. So when we're dealing with conversions, you're probably going to first go off of your data and not your conversion factors. So let's do a few conversions because that, everybody needs practice in conversions. So I'm going to start with 236 milligrams, and I ultimately want to put this into ounces, and I want to put it into pounds. So the first thing I'm going to do is I'm going to go look up my conversion factors, or my problem may actually give me my conversion factors. And for in this case, I'm going to get the fact that there's 453.6 grams is equal to 16 ounces. And this is a 1. So when I'm going to do my conversions, I'm going to get that 1 there. I also know that 1 pound is equal to 16 ounces. So we're going to use those as our conversion factors. And I'm going to get ready, and I'm going to use a couple of different pens here so that we can follow along both in color and in everything else. So I'm going to convert this to ounces and pounds. So first thing I'm going to do is I'm going to take my 236 milligrams, and I want to put that in grams because my conversion factor is in grams. And we're using the SI system, so luckily for us, and in your book, it's going to give you those prefixes to tell you how many milligrams there are to a gram. Well, there are 1,000 milligrams to 1 gram. And because it's the SI system, this is not going to control my significant figures. So like I said, I'm going to use a different colored pen here so that we know that we marked this out. So at the end of this calculation, I'm actually going to have an answer in grams. But I want to take my grams to ounces, so I'm going to do the next conversion factor. I want ounces on top, and I want grams on the bottom because I want to be able to cancel that out. So I'm going to have my 16 ounces on top, and I'm going to write, and that's going to be my ounces, and I'm going to have my 4, 5, 3, 6, 9, and I want to go ahead and put this in terms of red, so this looks, so we can kind of make it, my grams cancel, and I'm ultimately going to have my answer in ounces. All right, so let's plug this into the calculator and let's do this. So I'm going to plug it in the calculator. I want to take my so I've got it so you can see it. I'm going to take my 236 times, actually, divide by 1,000. That gives me my first part. I'm going to multiply by 16. I'm going to divide by 453.6. And you see that my calculator gives me that answer. Okay? Well, if I plug that into WebAssign, or if I plug that into Connect, it's going to go, I don't have the right significant figures. In fact, what the calculator gives me is much more significant figures than I want. Now, I'm not going to use the conversion factors to control my significant figures. I'm going to actually use my measurement. And my measurement is in 3 significant figures. So I'm going to write this in 3 significant figures. So I get 0, 0, 8, 3, 2. This is a placeholder. That's a placeholder. That's significant. That's significant. That's significant. I have 3 significant figures on both sides. All right, one of the things we haven't talked about is rounding, and we'll get to that in just a second. But for right now, that's how I'm going to look at it. Now, if I want to make sure everybody understands, I can put this into scientific notation, and I know it's going to be 8.32, and it's going to be times 10 to something. And on this calculator, if I do the second function, I can have it put it in scientific notation, and it tells me it's 0.03. So as long as I've punched this in the calculator correctly, I know that that's how many ounces I get. Well, I also want to convert it to pounds, so I'm going to stick with this. I'm going to get my 0.00832 ounces, and I want that in pounds, and 1 pound is equal to 16 ounces. My ounces cancel, and I end up with taking this, divide that by 16. If I leave it in scientific notation, it's 5.20 times 10 to the minus 4 pounds. so that you can actually get those values. Now, again, we're not going to let our conversion factor be the one that's controlling our significant figures. This tells me I have 3 significant figures and I'm utilizing my calculator to get there. So that's one way that you can do the calculations. So let's do another real quick conversion. I got to get a different piece of paper here and we can do that conversion. So I've got my piece of paper and we want to do, I want to convert 245 meters per second to feet per minute. I want to actually make that conversion, 245 meters per second to feet per minute. So let's get our conversion table out. I have 1 foot is equal to 30.5 centimeters. So we'll use that one. I have that conversion factor. 1 foot is equal to 30.5 centimeters. I know that 100 centimeters is equal to 1 meter. And I know that 60 seconds is equal to 1 minute. So if I start out with 245 meters per second and I want to convert it to feet per minute, I'm going to go ahead and put my 245 meters per second. I need to be in feet, but I've got my conversions here, so I'm going to go ahead and convert my meters to centimeters. So I'm going to put this as 100 centimeters is equal to 1 meter. And I know that I want to be in feet, so I'm going to have 1 foot divided by 30.5 centimeters because that's my conversion factor. So what I'm going to do, with this calculation, I'm taking my 245 meters per second and I'm going to end up being in feet per second because my meters cancel out, my centimeters cancel out, I'm left with feet on top, I'm left with seconds on the bottom, and I get my feet per second. So let's plug it into the calculator. So I'm going to get my 245 times 100 divided by the 30.5, and I get a number that looks like this. Now, again, we don't want our conversion factors to be the ones that are controlling our significant figures. This has 3 significant figures, and we want to be in 3 significant figures for our answer. So I'm going to write 8.03 times 10 to the second feet per second. If I want to see it in our normal, this is going to be 803 feet per second. Well, I really want my answer in feet per minute, so I've got to make that conversion there. And normally what we do when we're doing our calculations like this, I'm going to carry an extra digit for my calculations as an internal calculation. So in this case, I have a 7, so I'm going to have a round up. So this is going to be 803.3, and this is feet per second. And we know that there are 60 seconds in 1 minute, and I want to make sure my minutes are on the bottom because I want my answer in minutes, so I get feet per minute, and I'm going to multiply that times 60. And now I'm going to go ahead and do my rounding to 3 significant figures, so you see what the calculator says. And so this is going to be 48200. This is a placeholder, that's a placeholder, that's significant, that's significant, that's significant. So I'm got 3 significant figures. So 245 meters per second works out to be 48,200 feet per minute. So you can get that kind of a conversion factor. Now, that's how you normally do conversions, but when we deal with temperature, we end up doing a few weird things because our conversion factors for temperature are a little different. So if I'm going, we have 3 temperature scales. We have Kelvin, we have Celsius, and we have Fahrenheit. And these are all different ways of looking at it. So temperature in Kelvin is going to equal the temperature in degrees Celsius plus 273.15 degrees. So if I start with a temperature in Celsius, and I'm going to use 63 degrees Celsius, I'm going to go ahead and put in my 63 degrees plus my 273.15. If I do that in the calculator, this is going to give me 336.15. And with Kelvin, we typically don't have a degree symbol here, so that's why we lose that. But my original one is done to the ones place in my number, so I'm going to plug in to my answer system 336 Kelvin. And I want to have my units to show my units. If I want to convert that to Fahrenheit, the temperature for degrees Fahrenheit is equal to 1.8, and you can find different types of conversions for Kelvin or for Fahrenheit and Celsius, but this is the one that my Concepts of Physics or Concepts of Chemistry book uses, so we're going to do that, and that's plus 32 degrees, so I'm going to do my 1.8, and I'm going to put in my 63 plus 32 degrees, and I'm going to do that calculation. .8 times 63 plus 32 gives me 145.4. This is in degrees Fahrenheit. That's what my calculator provides, but I only keep it to the ones place, so I'm going to report it as 145 degrees Fahrenheit. So that gives you a couple of examples, kind of works through some of those significant figure issues. We're going to be going over it a little bit more in class, but hopefully this will get you started on all your homework.